All right. How's everybody doing today? Today we're going to be starting a new chapter, and it's going to start here with chemical bonding, and then eventually we'll also be taking a look at something called balancing chemical equations. But we're going to start with chemical bonding today. We'll be looking at over the next couple of days what a chemical bond is, what is it all about, and then we're going to take a look at three different types of chemical bonds. So let's get started. In your notes, you have a list of basically 14 questions, and by answering those 14 questions together, you're going to hopefully have a good introductory understanding of what chemical bonding is all about. Now, there's a lot more detail that we could get into. You'll get into that in the future in high school and college, but we're just going to do a little introduction so that when you do come back to it again in the future, it won't be completely new to you. So let's take a look at the first question. And the first question is, what are valence electrons? Now, valence electrons are something that we've referred to. We haven't necessarily used this term very much yet, but we have talked about the fact that that electrons in atoms are found in the electron cloud, which is around the nucleus of the atom. The electron cloud is made up of several different layers or levels or energy levels. Sometimes they're even referred to as shells. The closest one to the nucleus, we've talked about when we were talking about the periodic table. We've talked about the fact that that holds a total of 2 electrons, so it can have 0, 1, or 2 electrons in it. Once that shell or level is full, then electrons start to populate the next layer or level or shell. And the second one can hold up to 8. Same with the third one, and for the most part that continues on. There are some that can actually hold more than that, but they're considered full at 8 for our purposes that we're talking about here. So valence electrons are the electrons that are in the outermost energy level. So different atoms, depending on how many electrons they have different numbers of levels, but whatever their outermost level is, whatever electrons are in that outermost level, those are the valence electrons. They are the most loosely held, which means they're the easiest ones for the atom to lose or have stolen away by another atom. They're loosely held because they're further away from the nucleus. The nucleus is positively charged. The electrons are negatively charged. So there's an attraction between them. But the further away they are, the less the attraction. It's kind of like if you hold two magnets and you hold them really close, they're going to attract one another very easily. However, the further away you hold them, the less of an attractive force there is between them. All right, so that is question number 1. Let's start to take a look at question number 2. How is the reactivity of elements related to valence electrons? All right, so the number of valence electrons that an atom has, in other words, the number of electrons that they have in that outer shell, in that outer level, that is what determines the ways in which the atom will bond with other atoms. So chemical bonding is all about the valence electrons, all right? Understanding that these outermost electrons are what causes chemical bonds to happen is really important. Down here at the bottom of near the bottom of our screen, you can see little diagrams. These diagrams can be used to indicate just how many valence electrons a particular element has. So lithium, it has 1 dot by it, which means it has 1 valence electron. Beryllium has 2 dots, therefore 2 valence electrons, typically. Boron, 3 valence electrons. Carbon, 4. Nitrogen, 5. oxygen 6, fluorine 7, and then you can see neon down here has 8. All right, now it's kind of interesting, moving on to question number 3, we can actually use the periodic table to help us predict with some elements how many valence electrons they're going to have. So question number 3 says, how can you use the periodic table to predict valence electrons? Well, generally speaking, for at least a large portion of the periodic table, the number of valence electrons is either the same as or at least related to the group number. So for instance, over here in groups 1 and 2, group 1, all of these elements in group 1 have 1 valence electron. That even includes hydrogen. Okay, in group 2, all of these have 2 valence electrons. Now, unfortunately, the transitional metals here, transition metals in groups 3 through 12, don't really have a good way by looking at the periodic table of predicting their valence electrons. However, if we look at group 13, 14, 15, 16, 17, and 18, all you have to do is subtract 10 from each number, so take away the tens column, and that will tell you how many valence electrons there are. So in group 13, there are 3 valence electrons. Group 14, there are 4 valence electrons. Group 15, 5 valence electrons. And then group 16, 6 valence electrons, 17, 7 valence electrons, and just in case you couldn't tell, in group 18, we have 8 valence electrons. Those are your noble gases, remember. Their outer electron level, their outer shell is full, and therefore they are pretty much non-reactive. Okay, here's another diagram that uses the Lewis dot diagrams also to kind of show how these work. Notice again, the transition metals have just kind of been blanked out because they don't really follow the pattern. But here are our elements with 1, 2, then we skip over here to group 13. Whoops. Group 13, and we see they have 3, and then 4, and then 5, and so on and so forth, until we get to group 18, which has 8 valence electrons. All right, let's move on to question number 4. What makes atoms unstable? What makes atoms unstable? All right, well, we talked about this a little bit when we talked about the periodic table too, because we talked about, for instance, the alkali metals and the alkaline earth metals and the fact that they tend to react sometimes very violently with other substances. That means that they are unstable. And what causes instability? Well, it's when the valence electron shell, okay, that outer layer, that outer level, when that is not completely filled, then that causes atoms to be unstable. The closer it is to being empty, the more unstable it becomes. Okay, so definitely atoms that have either 0 electrons in their outer shell or 8 electrons in their outer shell are very stable. All right, they have no need to try to satisfy that outer level. So they are very stable and have no desire to react with other elements. However, they will sometimes gain, lose, or share electrons to either empty out or fill out or level. And that tends to happen more if an atom has between 1 and 7 electrons. They want to be able to have full electron shells. And as we're going to see, it's possible to have a full electron shell or a full electron level by sharing electrons as well as stealing them away or giving them away. So sometimes they steal them and gain them, sometimes they give them away or lose them, and then sometimes they will actually share electrons with another atom, and the electrons will actually go back and forth and be a part of both atoms, thereby completing their shell. All right, so here we get to the question. Here it is. What is chemical bonding? All right, what is chemical bonding? Well, it's when two atoms join together to form a new substance. So the joining of atoms to form new substances. This is a chemical bond. When hydrogen and oxygen come together and form water, H2O, okay, chemical bonding has taken place. When sodium and chlorine come together and form sodium chloride, a chemical bonding has taken place. So chemical bonding is the joining of atoms to form new substances. So then the question becomes, well, why do atoms bond? Well, we've sort of talked about that. We know that atoms want to be stable. We've talked about that a little bit. The fact that they want to have that full valence electron shell. Well, sorry, I went through that just a little faster than I thought I was going to. So this is what causes atoms to bond, is their desire, keeping in mind they don't have desires the same way we as humans have desires, but their desire, their need to be stable and to have that full valence electron shell. That is what causes atoms to bond. All right, question number 7. Okay, we've asked what chemical bonding is. We've asked why do they bond? Well, what is the chemical bond? What is a chemical bond? Well, it's actually a force. It is not matter, so it is not made up of atoms itself, but is a force that actually holds atoms together. Okay, so we know from way back, much earlier in the year, that a force is a push or a pull. Okay, and so in this case, a chemical bond is a force or a pull between two atoms that holds those two atoms together. And you can see here in the picture, it talks about like nonpolar and covalent bonds and ionic bonds and things like that. We're going to get to some of that, not go into a huge amount of detail, but we are going to eventually get into some of that. And so, but before we do, let's actually take a look. So here we have a picture on the left-hand side of some sodium. Sodium is we've talked about it before, it's a silvery metal, very soft. You can cut it with a knife. It is quite poisonous to human beings, but it is definitely metal. And then if we take that and we add that to chlorine gas, a green gas, highly toxic to human beings. We combine those two toxic things together, one a silver metal, the silver soft metal, the other a green chlorine gas. And if you put them together, you actually get a huge explosion, all right, a fairly violent reaction. And the end product after that reaction, because the sodium has the sodium has two valence electrons, and the chlorine has, nope, take that back. The sodium has one valence electron, excuse me. The chlorine has 7. So sodium would desperately like to get rid of its 1 electron. Chlorine would desperately like to gain 1 electron, and so they react when they come close to each other. That electron jumps basically from one to the other. The reaction takes place and we end up with these nice, pleasant little crystals of salt that are actually necessary to our diet. Keeping in mind everything in moderation. Too much salt, not good for us, but our bodies do need salt in order to survive and for our muscles to work properly and things like that. All right, there are 3 different kinds of bonds that can form. So what are those 3 ways that atoms can form bonds? Well, one of them is known as an ionic bond. The second one is known as a covalent bond. And the third one is known as a metallic bond. We're going to get into those more tomorrow. But for now, ladies and gentlemen, just know that those are our 3 kinds of bonds. Thanks a lot. We'll talk again later.